Hi class. Today we're going to talk about proportions. And if you remember, a proportion is just an equation that shows two equivalent ratios. As just a brief reminder, let's go over what a ratio, equivalent ratio, and proportion are. So a ratio is just one value or one quantity compared to another using division. That's what that horizontal line is there for. When we're talking about equivalent ratios, we're setting up a single ratio and saying it is equivalent to another. For example, 3 to 4 is equivalent to 6 to 8, which is equivalent to 9 to 12. A proportion is just taking it one step further, taking two ratios, for example 3 to 4 and 9 to 12, and setting them equal to one another. That's the only difference between an equivalent ratio and a proportion, right here, the equal sign. So now that that's out of the way, let's go over example 1. For example 1, we're talking about triangles and circles. And I'd like you to tell me the ratio of triangles to circles. Whenever we're talking about a ratio or a proportion, whatever comes first is the first thing that you list. So, for example, triangles is listed first. In our ratio, triangles has to be listed first. Because circles is second, that's what's on the bottom of our ratio. Can you tell me the ratio of triangles to circles now? If you said 4 to 2, you are correct. Now remember, it's set up just like a fraction would be, but it's not a fraction. It's one quantity compared to another. Now, if I said to create an equal proportion, can you do that? If I look here, I notice I can break up my triangles into two equal groups. Two triangles here and two triangles here. Similarly, I can take the circles and I can make two equal groups like this. So now looking at one individual group, the ratio is still the same. I just made two groups of the same ratio. So 4 to 2 is equivalent to 2 to 1. Because I use the equal sign in between there, that tells me it's a proportion. Let's talk about example 3. Let's talk about example 2. Example 2 deals with cross products. Now, with cross products and proportions, cross products and proportions are equal to one another. Let's take a look at one example. I have 3 to 4 equal to n to 16. And again, whenever there's a variable, that's what we're looking to find out. So we'll use cross products. I always like to start on the side that has the variable. So we'll do 4 and n. Cross product, product meaning multiply. So we have 4 times n is equal to 3 times 16. Now we just have to solve this simple equation. The first thing we have to do is simplify the side that does not have the variable. So 3 times 16 is 48. And over here I have 4 times n. Do you know how to solve this equation from here? Take a moment and do it. If you said divide by 4, you are correct. Remember, we're doing the inverse or the opposite of whatever's listed. Here is multiplication, the inverse is division. So over here, these 4's cancel out. I'm left with n equal to 48 divided by 4, which is 12. So up here in the original proportion, our answer is n. Our answer is 12. Let's do another one. Five over 6 is equal to n over 18. Now before we solve this one together, see if you can use the same method that we used on the first video. Let's take a look at another one. Here we have 5 to 6 is equal to n to 18. And again, we're using cross products. So I always start with the side that has our variable. And we multiply the one that's on the opposite end. So here we have 6 times n. And we have 5 times 18. Set them equal to each other because it is a proportion, and we solve. 5 times 18 is 90, and that's equal to 6n. Remember, multiplication, the inverse of that is division, so instead of multiplying by 6, we are going to divide by 6 to both sides. These cancel out. I'm left with n is equal to 90 divided by 6, which is 15. If you ever do want to double check that your proportion is right or your answer within the proportion, take your original one and plug in the 15. So now when we're here, all we have to do is ask ourselves, how did I go from 6 to 18? I multiplied by 3. Does that also work for 5 and 15? If it does, you are correct. Here's our last example. This is example 3. So I have a dog. She is 10 years old and her name is Della. She is a part border collie, a little mix of a lab, and a shepherd. So we're talking about her pet vitamins. And I'm wondering, how much do I give Della? Well, the directions say they get 1 teaspoon for every 20 pounds. And this is a rate because I have 2 different labels. It's a ratio if I were to just have the digits 1 to 20, but because I have 2 different labels, that's what makes it a rate. And I'm going to set it equal to teaspoons on top again because teaspoons is here, and pounds down here because pounds is on the bottom here. You have to make sure that the labels are set up next to each other. Della is 65 pounds. So the question is, how many teaspoons of pet vitamins am I going to give her? Well, if you see here, this is set up just like the regular proportions that we've done. The only difference is I now have labels. We're actually not going to worry about the labels right now. We start on the side that has the variable, and we multiply down and across. So we have 20 times x is equal to 1 times 65. Now we simplify. I leave this side alone until I simplify the side opposite our variable. So 1 times 65 is 65, and this is 20 times x. Now that I have one variable or one value, now that I have one constant on this side, now I can work on this side. Remember, our number one goal is to get the variable alone. And because of 20 times x, the inverse of multiplication is division. So I'm going to divide by 20. These cancel out, and I'm left with x. And sometimes you might need to do your division on the side. That's absolutely fine. Let's do that now. Here's my decimal place, and because I'm dividing by 20, I can cancel out that 0 and move the decimal place over 1. So now I have 2 goes into 6.5. Bring the decimal place straight up so I know where it goes. 2 goes into 6 3 times. 3 times 2 is 6. Subtract, I get 0. Bring down the 5. 2 goes into 5 2 times. 2 times 2 is 4. Subtract, I'm left with 1. I cannot leave this 1 down here, so I have to add another 0. If we remember from dividing by decimals, add my 0 here. 2 goes into 10 5 times. So our answer here is x is equal to 3.25. And if we look back up to the beginning, we notice our variable is teaspoons. So when I give Della her vitamins, I have to make sure that I give her 3.25 teaspoons. Okay, there are your notes. Make sure to have them copied down. They will be helpful with our project.